Hi, welcome to my channel. Today, I'd like to talk to you about Python generators, what they are and what they're good for. What is a generator? A generator is a lazy iterator. Try to say that 10 times fast. You can loop over lazy iterators like a list. Also, generators do not store their contents in memory. Definition. The Python docs describe it this way. Generators are a simple and powerful tool for creating iterators. They are written like regular functions, but use the yield statement whenever they want to return data. Why use a generator? First and foremost, they're fun. I started using them more since I started this tutorial, and I found them really useful. If you want other reasons, though, they would be first, that generators use less memory. Whole lists of items don't have to be stored, and they are faster. As we will see, sometimes they are much faster. Let's talk more about speed. I wanted to test the claim that generators were faster. I tested two kinds of generators. Simple generators, which are really just list comprehensions without the list, and generator functions. Let's take a look. List comprehensions. Here we have a simple list comprehension. It's one I use all the time. In fact, if you've seen other videos of mine, you've probably seen this before. This particular bit of code reads in a list of strings, then removes any white space and empty lines. I timed how quickly it executed and found the operation took, on average, 170.6 milliseconds. I ran the same program again, only this time swapped out the square brackets for round ones, and in so doing created a generator. To be honest, I was skeptical about the comprehension being quicker, but it was. In fact, it was almost twice as fast, 171 versus 107 milliseconds. But I thought, well, maybe things will be different for normal functions, like this one. As you can see, all this does is increment a counter from 0 to max. I ran it a few times, and on average, it took 102 milliseconds to execute. So now let's look at this same function, but changed into a generator. But before we do that, I want to talk about the yield statement. Using a yield statement enables the function to produce a series of values over time instead of computing them all at once and sending them back as a list. The yield statement suspends the function's execution and sends a value back to the caller, but retains enough state to enable the function to resume where it left off. So now that we know what a yield statement does, here is the generation function I was talking about. This generator function does the same thing as the function we just saw. The first thing that jumps out to me is that it's simpler. There are fewer lines and there are fewer steps. Here we return a value if the counter is less than the maximum value, and then we increment the counter. But what's truly remarkable here is the average speed of the function. The generator function executes in only 2.6 milliseconds. That's incredible. As a list, it took 102 milliseconds. There's one more really important thing I want to go over when we talk about generators, and then I'll show you an example. Let's talk about the next function. Next takes a call to a generator and increments the generator. Here you can see that we access the generator through next G, and this is the output. In order to see how this works, or how it can work, I made a silly little program. Right now I'm in the process of creating a simple RPG. Those tutorials will be coming soon. And it often happens that you have an object, let's say an NPC. You want to give it a series of actions to do, but on its own time. So you don't want it tied into the game clock. Using a generator to feed such a critter actions comes in very handy. I created a very simple example to give you an idea of what I mean, and I've put all this code up on my GitHub. The link is in the description below. The critical function here is move. First we use next to get the next value from the iterator. If we go past the maximum allowable value, 100 in this case, then we create the generator over again. Then, depending upon whether next move contains up, down, right, or left, we move the square up, down, right, or left. If I were writing more than just a simple example program, I would have been more careful about the error checking. Here, I just make sure that the square stays on the screen. Now let's look at the generator function itself, getMoves. As you can see here, each time yield is called, a value, up, down, right, or left, is randomly selected and the counter is incremented. Simple. The only thing left for me to show you is the program running. Here it is. I hope you got something from this. Do you think you're more likely now to use a generator? Whatever the case, if you'd like to support this channel, please like and subscribe. Thank you for listening, and I'll see you in the next video. In the meantime, good coding.